Lesson 16 demo. Today we review exponential functions so that we can find and use derivative formulas for them next class. 1. Suppose an air freshener starts with 30 grams and evaporates. That's 30 grams of the chemical that makes the room smell nice. Write a formula for the quantity Q grams of air freshener remaining T days after the start if the air freshener decreases by 2 grams per day. Okay, so Q of T equals, so we started with 30 and then we lose 2 grams every day. So we're subtracting 2 times T, where T is the number of days. So that's a linear thing, losing 2 grams per day. But now we're going to assume that we decrease by 12% per day. Okay, again, we start with 30, but this time we are losing 12% per day. So we're going to be multiplying by something. But I don't want to multiply by 12% every day because that's going to give me 12% of the 30. What I want to do is write down an expression for what remains. If you lose 12%, then you still have 88%. So 0.88 would be our way of saying, take the 30, multiply it by 0.88. That's what you have remaining after 1 day. But if I want to know what I have after 2 days, I got to multiply by another 0.88 or 0.88 squared. And in general, we need to multiply by 0.88 to the t. So green linear, red exponential decay in this case. Okay, exponential functions, number 2, can be written in the form P of t equals P0 times a to the t or P0 times e to the kt. So in our case, we have this one, right? P0 is 30 and a is 0.88. Let's convert our answer from 1b into the other form, the other exponential form, P0e to the kt, and then we'll answer a different question. So here's what I want. I want the 30 times 0.88 to the t that I have to be written as P sub 0 times e to the kt. Well, I've got no choice about P sub 0. Clearly, I need to make P sub 0 equal to 30, so I'm going to ignore that. It's already done, and I'm going to write down the rest of this equation. Okay, trying to solve for the value of k. Now the thing is, those t's, they sure look like they're in like the same place on both sides, right? If I could only figure out what to do to get rid of them, I really like to just cross them both off. So here's the thing we're going to do. We're going to raise both sides to the correct power, and the correct power is 1 over t. And the reason I know that's the correct power is that I'm supposed to multiply the powers when they look like this. And t times 1 over t cancels. That's the goal, is to get rid of that t. So we did that to one side. We do it to the other side. And then again, those t's cancel because here you're multiplying kt times 1 over t. And so you just get k. And so then this simplifies to 0.88 equals e to the k. And we know that in order to solve this equation where the exponent is in the power, we need to use logs. And so I'm going to use ln. So I'll copy this equation again with a little bit of space here. And I will take the natural log of both sides. And then the natural log on the right-hand side cancels with the e. And so the right-hand side is simply k. And the left-hand side is ln of 0.88, which is the exact answer. We're going to get a decimal approximation from our calculator. ln on the left-hand side there, 0.88. Negative 0.1728. One, 2, 7, 8. Let's try that again. Okay, that looks good to me. And so then it says, so the follow-up question, oh, okay, so then let's write our final answer here. So what that means is that our original function, it was Q of t equals, so we had 30 times 0.88 to the t, but another way to write that is 30 times e to the kt, e to the negative 0.1278 t. It's only approximate here. Okay, so that's good. And then there was just one more follow-up question. It's vocabulary. It says find the continuous decay rate. So that's just the phrase that represents k down here. So if you have an exponential function written in the form e to the kt, then k is called the continuous growth rate or continuous decay rate. So negative 0.1278 or negative 12.78%. So we knew that we were losing 12% a day, and that translates in a continuous way. Instead of thinking of like taking 12% off once each day at the end of every 24 hours, works out to be the equivalent of taking 12.78% off at a continuous rate, right? Little bits of that 12.78% coming off at every moment of the day.